Okay, welcome back to Think Tank Online Learning. In this video, we're going to look on advanced double integrals. Okay, so I want to evaluate the double integral of 1 plus ln x squared under the square root divided by x. Okay, so first of all, if you to identify the order of integration which you are given, and when I say the order of integration, I mean in this case we are given dx, so that means we're going to integrate with respect to x first, and after that we're going to integrate with respect to y. You can't just integrate with respect to y then integrate with respect to x when we're given dx dy. Okay, then after that we're going to determine our limits. Okay, so I'm going to write the limits here. Okay, so for x, this is dx and this is the sign of the inner integral. So for x, that means x is equal to e, so I'm going to write x is equal to e, and also x is equal to e to the power y, and I'm moving on to y, and for y the outer integral, so y is equal to 1 and y is equal to 0. Okay, you have to write this, so we're going to use this information, so it's very useful. Okay, so now what we're going to do, let's integrate. Since we're integrating with respect to x, we have to integrate this with respect to x. Okay, so let's do that. Actually, as you can see, this is very difficult to integrate. So what we're going to do, let's try to ease this problem. So how we're going to do that, we're just going to change the order of integration. So by changing the order of integration, we mean we want to say dy dx, but you can't just say y dy dx. We have to also change the limits right here. So how are we going to change the limits? So we're going to use this information. So remember, this is a region, so that means it is bounded by curves and straight lines. So what are we going to do? Let's try to sketch this region in the xy plane, since we're already dealing with x and y. We don't have any other variable. So I'm going to sketch my xy plane right here. So this is y and this is x. Okay, so first of all, I'm going to start with the easiest graph. So this is graph with y equals to 1, just a straight line. So I'm going to go to the point when y equals to 1, and I'm going to write it here. This is y equals to 1. Then what is next? We have x equals to e. So don't get confused. E is a constant, and you know that when x equals to 1, just going to draw a straight line at 1. So it's approximately about 2.7 something, but I'm not going to write that value. I'm just going to write e right here, and I'm going to draw my straight line, and this is x is equals to e. Now we have x equals to e to the power y. Okay, so this graph, it may look difficult, but it won't if we okay, so let's try to put logs on both sides. So I'm going to have ln x here, and here I'm going to have this is equal to ln e to the power y, and we know that ln e to the power y is same as saying y, since the natural logarithm of the exponential, it's 1. Okay, so now if our graph ln x equals to y, and everyone know that graph y equals to ln x, and that graph casts the x-axis at 1, and it is going right here. So this is y is equals to ln x. Okay, so some of you may be asking, how does he know whether this line are intersection right here? Okay, so how do I know that? I'm just going to solve this equation and this equation simultaneously. So if we say y equals ln x, then at y equals 1, we're going to see they're going to intersect at this point. And if you solve this one with this one, we're going to get this point. Okay, so now we're almost now. Remember, on our problem, we're integrating respect to x. So let me just call this region R. So if integrating respect to x, that we're moving from this direction to this direction. So we're moving from here to here to here. But now we have to change. So we're doing the opposite. Okay, we're not doing the opposite, but it's like the parallel. Okay, so I'm moving upwards, downwards to upwards. Okay, since from y, y is increasing this direction, so I want to change it. I want it to move in this direction. Okay, like that. Okay, so now if we want to integrate respect to y, that means all our limits should be in terms of x. Okay, so like here, y equals ln x, that is good. Y equals, we don't need x equals ln y. No. We want to integrate respect to y first. Okay, so now what are our limits? Okay, I'm going to start with y. So the lower boundary for y, it's 0. Y is equals to 0. think that this is to C. Y is starting right here, and Y is going up to this point, so this point is 1. Okay, I'm not going to write 1. Why? What is the value of Y here? I don't know. The value of Y here, I don't know. The value of Y here, I don't know. But I can find the value of Y using this equation. So that means Y is changing. So I'm going to use this equation. So that means the value of Y is ln x. That is the upper bound, which is governing this region. Okay, so now I'm going to x. So for x, since we're integrating with respect to y, just going from this direction, we're going to write the first point, starting point, and that is x equals to 1. And what is the end point? It's x equals to e. Okay, like this. Okay, and now what we're going to do, we're going to change our the order for integration. Now you can change it with confidence. Now for x is going on the outside since we've flipped them. Okay, so the lower limit for x, which is 1, and the upper limit for x, which is e, as you can say, it was starting from this direction to this direction. If you're getting confused, you can say x equals to 1 and x equals to e. You're going to see that e is bigger than 1. Now going to y, we've said the lower bound for y, which is 0, and what is the upper bound? And we've said the upper bound is ln x. Now let's write our problem. 1 plus ln x squared. We're not going to change anything here. The order of integration doesn't affect our integrand. That doesn't change the value of our integrand. So you're going to say dy dx like this. Okay, so now we can first integrate with respect to y. So we don't have any y variable here, and that is good for us. So we're going to treat y as 1. So remember, if we integrate with respect to y, our x is constant. Okay, so that means I'm not going to touch x. I'm not going to add something to x. So I'm just going to leave x as it is. Okay, so now let's integrate with respect to y. Since we don't have y, we're going to say, let's say we have 1 here. Okay, so if we integrate a constant, let's say if we integrate 2 with respect to x, it's going to be 2x. If we integrate 3 with respect to y, it's going to be 3y. So let's do that. So for x, we're going to have 1 and e right here. And for y, we're just going to put y, and we're going to put the square root of 1 plus ln x squared divided by x. And we're going to put our limits 0 to ln x and dx like this. Okay, we've made a lot of progress. Now we're going to say lower bound minus upper bound minus lower bound. So it's going to be 1e, and we're going to have ln x right here multiplied by 1 plus ln x squared divided by x minus, and we're going to say 0 1 plus ln x squared divided by x, and I'm going to say dx like this. Okay, so what we're going to do next, so this is going to be 0 since we're multiplying everything by 0. Okay, now going to be right here, so I'm going to have ln x 1 plus ln x squared divided by x dx. Okay, so we now need to integrate with respect to x. So it's still tricky. So okay, so each and every time we see an expression or we have a square root, think of integration by substitution. Okay, so we're going to use integration by substitution. That is a powerful method. And when you are reversing the order of integration, that you have to know that the only method that works. Okay, so this is method that works is integration by substitution. Okay, so what are we going to do? Unfortunately, we're not given substitution. You have to think of it yourself. Okay, so what you have to do, just going to look at the expression inside the square root, and we're going to let that expression be equal to n letter that you like, which is not included in the integration process. And I'm going to choose u, which is the common one. So I'm going to say let u be equal, what is inside the square root? That is 1 plus ln x squared. Okay, so now we're going to differentiate. This is basic differentiation, okay, from calculus 1. So I'm going to say du dx. Okay, so remember, this is not this is no longer about main variables, so we're just going to do basic integration. Okay, so basically differentiation. So we're going to use chain rule. If you differentiate 1, what we're going to get is just a constant, so we're going to get 0. So here we're going to drop the power 2 ln x, and by the chain rule we have to find the derivative of ln x, and that is going to be 1 over x. Okay, and this is equal to 2 ln x over x. Okay, and now we have to make dx a bit of the formula, and if we do that, we're going to see that dx is equal to x divided by 2 ln x du. Okay, and that is very good. Now we're going back. We're going back here. So still we have these limits, we don't want to change them, and we're going to have ln x, and we're going to have the square root. So instead of writing this big thing, I'm just going to write u, since I've said that that thing is equal to u. Okay, so I'm going to write u here, and I'm going to divide by x, and for dx I'm not going to write that. I'm going to write x over 2 ln x du. Okay, so now it's time. We can't say, oh, we have ln x, we have ln x, and we have x, and we have x. Okay, so we've made the progress. So that means we're now left with 1e. I'm not going to write u root 2 as root 2. I'm going to write it u to the power 1/2 divided by 2 du. Okay, so let's integrate with respect to u. We're just going to add the power and divide by the new power. So I'm going to say 1/2. I'm going to pull 2 right here. Okay, and I'm going to have u, say 1/2 plus 1, that's going to be 3 over 2 divided by 3 over 2. And what we're going to do, we're going to put our limits 1 to e. Okay, and see, like this. Okay, so here what is going to happen here? Okay, so we can just put e right here. We have said that this is u, so we're going to substitute u back, right? Okay, so let's substitute u back. So this is going to be 1/2. Now going to here for u, it's 1 plus ln x squared, and remember it's to the power 3 over 2, and we're going to divide this by 3 over 2. Okay, and we're going to put our limits 1 and e. Okay, so we're going to say upper bound minus lower bound. Okay, so let's do that. Okay, so I am going to do it right here. Okay, so as for e, we know that ln e is 1. So I'm going to say 1/2 multiply by 1 plus 1 here. Its squared is still remain 1 to the power 3 over 2 divided by 3 over 2. Okay, and we're going to say minus 1/2. We're going to have 1 here, and we know that ln 1 is 0, so we're going to have 1 to the power 3 over 2. Okay, so that is not going to change anything, so we're going to have divided by 3 over 2, and what is going to be our answer? So the answer in decimal is going to be 0.609475. You can just write it in exact mode. So this is the answer. So thank you for watching. Don't forget to subscribe.